Welcome back. We're working on standby again today. Last episode we made the foot and the frame. Today we're going to build the cylinder and the piston. Here we have the drawing for the cylinder. You can see it's not very big, 1 inch by half by 9/16. Got this little piece of 3/4 square, 5/8 square would be a little more convenient, but it's okay. I have a milling machine. Not very big bore, 3/8. I'm going to ream it. Maybe it'd be a little more important if I wasn't also making the piston with it. I'm just going to ream it and make the piston a match. I just got done squaring up this block for the cylinder, and I came back to the plans and I realized something. That bore has a flat bottom. Those hidden lines there are about these 45s. Flat bottom. I can't ream that. There'll be a drill cone at the bottom of it, and I'll probably bust through the end. I get to bore that on the lathe. So, to the lathe we go. I just ground this boring bar to actually fit into this tiny 3/8 bore. This will be interesting. It's cutting just fine. Oh my god. That's crazy. That's actually working? I can't believe that's no way. Granted, I am going unbelievably gentle on it, but that's crazy. Wow. Okay. Oh, the finish in there doesn't look bad either. Hey! Sweet. That's actually a little chip. Oh my gosh. No way. That's awesome. I just wanted you to get a sense of what I can see while I'm doing this boring operation, which is absolutely nothing. I can't see a single thing. This board is about 3 thou oversized. Okay, I think I know how this happened, and I know how to not do it again. So let's talk about that. So when this boring bar that had to grind really skinny to get in this tiny little bore enters the bore, it deflects. Okay, everything is a spring. So I have a piece of spring steel for an example. So when I bring the tool in, if it's a very light pass, you see the tool doesn't deflect very much. But if I try to cut deeper, when it should be cutting here, it deflects and cuts less. So when I was taking my measurements, it was after, 5 thou depth of cut passes with a lot of deflection, and my last 2 cuts were 1 thou. So it was cutting more than I thought because there was less deflection. I was assuming a perfectly rigid boring bar, which, come on, look at it. Man, I shouldn't have. So, light cuts before measuring next time. It's not as much of a problem as you might think, since I'm making the cylinder also to match. So, it's just a little bigger bore. It's okay. I'm not proud of it, but it's serviceable. This is a really great example of how to use the tap follower that I made. Tap in, push up, let it come down, you're in your hole, and you're tapping. Boom. Super easy. Now once you've got the mill in the right spot, you can just go. Your threads are going to be nice and straight. Really just go for it. I've always been scared that I'm going to put a side load on my tap, snap it. It's not going to happen with this thing unless I hit the bottom and twist the tap off. And taking it back out is just as easy. It just threads itself back out. And we're out. Easy. So there's the cylinder finished. Bore, the threads, the intake hole, which is also the exhaust hole. This brushed finish you're seeing is just some 1000 grit sandpaper. Just a little bit of a, you know what I'm saying? I left that as a machine surface, that as a machine surface, and these 45s. So I got this neat contrast of brushed and just bare machine, which almost looks polished. Make sure this thing fits. Oh no. Oh, this is very not good. Oh. Oh. That kills me. Oh no. I mess up a lot. Those two holes are in the wrong spot. In my DRO, I edge found on this side. We're 1/8 of an inch in. Did those two holes. Those two holes are in the right spot. And then I went to 750. I need to go to 750 plus 125. That reference is not this edge. It's with this. It's this hole. So now they don't line up one bit. I've had to think. Here's what I'm going to do about this. I'm going to make new holes over here. They shouldn't meet with those holes. Like if I made holes in the right spots here and here, they shouldn't hit these holes. So, and these will be covered up. That's not the most critical part of the sealing surface. This whole block makes me sad. Yes, it was a 5-minute fix, It was a 5-minute fix that should have had to happen. This has been a bad machining week for me. That's rough. Let's put it together now. Fits onto the frame real nice, actually. Really, barely even feel a step on there. And that's probably just because I'm locating with screws, so if I turn it a little bit, it might be even better. I don't know if that's supposed to be there, that little offset. It'll be okay, though. At least my extra screw holes are hidden. I think it actually looks pretty good. Time to make the piston. I just got to remember I'm 3/5 over, so that needs to be 378. Got this nice piece of brass. That'll do nicely. This should be easy. I said that about the whole engine, but this should be easy. The fit is unbelievably close right now. I think it needs to be just a little looser than that, though. It needed just the tiniest bit of sanding, but now it just fits right on. And the real question is, does it pass the pop test? Yes, it does. I've ground another tiny little boring bar. That's my pinky, by the way. I'm giving this a 75% chance of just snapping off immediately. Here we go. Oh, way too deep. That's so working. There is the cylinder and piston complete. A few hiccups along the way, but it should still work out just fine in the end. And of course, the pop test is perfect. Thanks for watching.